So in this video we are going to discuss about tree sort. So what is the definition of tree sort? A tree sort is a sorting algorithm that builds a binary search tree. So this is most important. What is it? We are going to build a binary search tree. Okay. So I want to tell you one more information. Binary tree is different. Binary search tree is different. Okay. So we are going to build a binary search tree from the elements to be sorted and then traverse the tree in order method so that the elements come out in sorted order. Okay, we are going to take these numbers one by one and we are going to construct a binary search tree. It is nothing but BST. Okay. So we are taking the first number. We put the first number as a root and we have to take the second number, compare with the root, and 15 is a current number, 20 is a root number, 15 is lesser than 20, so that's why we go to left hand side, we put that number. Okay, and we are taking the third number 30, compare with root to node, 30 is greater value, so that's why we go to right side. Taking 5, compare with 20, lesser number, compare with 15, lesser number, so we are constructing, we are inserting here. We are taking next number, compare with 20, it is a lesser value than 20, so that's why we come to left hand side, compare with 15, 18 is a greater value, so that's why we come to right hand side and we place this value here. Taking next number 35, compare with 20, 35 is a greater value, come right side, compare with 30, so greater value, so that's why come with right side, we are inserting into the right side of 30. Next number is 23, compare with 20 greater value, so compare, we come to right side, compare with 30 lesser value, so we are attaching this number as a left child of 30. We are taking next number, it is 2, compare with 20 lesser, compare with 15 lesser, compare with 5 lesser, so that's why we are inserting 2 as a left child of 5. Next number is 8, compare with 20 lesser value, compare with 15 lesser value, compare with 5 greater value, so that's why we come to right hand side, we place it in the right child of 5. 16, compare with 20 lesser value, compare with 15 greater value, compare with 18 lesser value, so that's why we insert 16 as a left child of 18. Next one is 19, compare with 20 lesser value, compare with 15 greater value, compare with 18 greater value, so it is stored in right child of 18. Next number is 21, compare with 20 greater value, compare with 30 lesser value, compare with 23 lesser value, so that's why 21 is placed here. 28, compare with 20 it is greater, 30 it is lesser, 23 it is greater, so that's why it is added here. 32, compare with 20 greater value, compare with 30 greater value, compare with 35 lesser value, so it is stored as left child of 30, 35. 40, compare with 20 greater, compare with 30 greater, compare with 35 greater, so that's why 40 is stored here. What is the necessity of constructing BST means? After constructing BST, as per the definition, we follow the in-order traversal. In-order traversal. So in in-order traversal, what we do? We have to come to leftmost side first, left, top, right. In-order is nothing but left, root node or top, then right. Whether we come it as just we note it down, it is left, top, right. Okay, so we come to the leftmost side, we are writing this number 2, top 5, then 8, right is 8. Then we come here, as per this node, this is left, okay, top 15, then right. When we come right, this is also have a left child, so that's why again left. 16, 18, 19, then we come to root 20, because left is over, top 20, then we come right. After coming right, we have to go to left. 21, then 23, then 28, then 30, 30, 35 have a left child, so that's why 32, then 35, and then 40. Okay, so this is what is that? After constructing a binary search tree in the unordered list, after constructing binary search tree, when we go for in-order traversal methods, we are getting the numbers in sorted order. So this type of sorting, it is called a tree sort. Okay, so algorithm is also given here. In this tree sort, there are two algorithms are given. One is inserting an element. So we already have idea how to insert. Inserting an element, that is, there are two parameters we are giving, two variables. One is node, another one is value. Okay, so if node equal to null, what it means? If node equal to null means there is no tree in that. Okay, so in the initial stage, what is that? When we are taking 20, tree is null. Okay, so that's why what we do, return node value. So we are taking 20 as a only single node and we return that value. Okay, suppose the node is not null, else if means we are executing the else if value is less than or equal to node value. What is that? The current value is less than or equal to node value. What is that? The previous value. So it is lesser value. If it is lesser, node left equal to insert node left value. So we are taking 15, we are inserting as a left node of that particular node. Suppose it is not a lesser value, if it is greater value, we come to else part, node right. Suppose we are taking 30, 30 is the greater value than root. So we compare with root, 30 is a greater value. So automatically the control comes to else part, node right equal to insert node right value. It means that we go to right side, we inserting one node and we are storing the value, current value in that node. So through this way, we are executing the insert algorithm again and again, and we are inserting elements according to the right position of the particular tree. Okay, particular BST. So this is inserting procedure. What about traverse? Traversing, it is nothing but after insertion it is over, we have to traverse the node, each and every node in order traversal, then only I am able to get the ascending order. So we call the traverse in order of node. What is that? Traverse in order of node means the root node is given as a node here. What is that? We have to check it up if node not equal to null. If node not equal to null, what we do? Again we call the same procedure with node left. What is that? The control comes here, node left. So whenever the control comes here, it is a recursive procedure. So in the in-order recursive procedure, what we do? At each and every time we go to the left hand side. Whenever we go to the left hand side, what we do? We take the right hand side value, we put it in the stack. When after coming here, right value is there, 18 is put it onto the stack. Then we come to 5, right value is 8, put it onto the stack. Then we come to last node, hereafter there is no value, so that's why we are printing the node. Once again what we do? We are examining the right part. So we are calling the same procedure with node right. So node right is we are taking from stack and we are examining and we are taking the value. Okay, so whenever what is it? We go for leftmost node, we are executing and we come to the root node, we are printing that, then we go for right child. So through this way we are traversing the entire BST, that is binary search tree, and we are getting the numbers in sorted order. So we want to discuss time complexity also. There are three cases are there, we already know: best case, average case and worst case. And in this what is it, tree sort, best case and average case time complexity is big O of n log n. Why best case and average cases are big O of n log n means we already know that the binary tree, it is having the height of log n. Suppose I want to traverse one by one means it takes n time. So that's why the best case and average case, it takes order of big O of n log n time. And in the case of balanced binary tree, suppose the binary tree, it is not at balanced, it is left skew binary tree or right skew binary tree means one side it is very, what is it, deep enough, and the other side it is not deep enough. In those case, the worst case scenario, it is big O of n square. So we want to execute the n square time to find it out the particular value or constructing the binary BST, binary search tree. Okay, I hope you understand the logic.